Hello everyone, my name is Ihsan Khairir. I'm a math teacher. I've been a math teacher for about 15 years now, teaching in multiple levels. I've taught in the Malaysian school system. I've also taught in university and also in international school in IGCSE and now also in A-levels. I've been teaching math for all this time. And recently I have looked at the solutions or worked on the solutions for the recently concluded probability and statistics to A-level paper 970963 May-June 2025. And so I'm going to continue with discussing the solutions to this paper. And we're going on to question 3, which is 8 marks. All right, let's just go on to the question. A machine dispenses coffee into cups. The volume, V centimeter cube, of coffee in a cup was measured for a random sample of 150 cups. The results were summarized as follows. So this is the sum of V, which is 46,350, and the sum of V squared, which is 14,410,800. All right. Question A1, calculate unbiased estimates of the population mean mu and the population variance sigma squared. And this is 3 marks. I would believe that based on this question, the marks are given for correctly calculating the population mean, that's 1 mark, and 2 marks for correctly calculating the population variance, right? Simply because calculating the mean is so much simpler. All right. The question does say unbiased estimates, so we have to use the method, the formula in the MF19 for the unbiased estimates for mean and variance. Okay. So for the mean, the unbiased estimate of a mean is simply just the sum of the data divided by how many data there are. So the sum of V divided by N, in this case in our N is 150. So we just plug in those values, press our calculator, and we get 309. This is very nice number, 309, no decimals, we're done, right? That would be just, there you go. 1 mark there, too simple to be given any working marks for, so that's just that, that's 1 mark. Now for the unbiased estimate of the population variance, make sure that when you go to the MF19, you grab the formula for the unbiased estimate for the standard deviation. But since we are finding it for the population variance, we don't need the square root sign. So, and for an unbiased estimate of the variance, right, the only difference between the actual calculation of a standard deviation or variance compared to the unbiased estimate is that there will be a Bessel's correction here where ultimately we're going to divide the quantity that we calculated with n minus 1 instead of n. So be careful with the choice of formula because it does say unbiased estimates, and so if you actually use the wrong formula, you will not get the mark for calculating this. All right, so use the correct formula. In this case, of course, we're not using x, we're using v, so you'll see me using v here in this solution. So just plug in the values that we already know. The sum of v squared is here. It's 14 million and some things. And then we also plug in the value of the sum of v. And of course, we have to, don't forget, to square it first, right, before we do the division. Right, just plug in carefully. And at this point, you are free to just press your calculator. It's only 3 marks. And the working for the extended working of this is not really that important. But you have to press your calculator very carefully. For this one, I would suggest that you use the latest version of the Casio ClassWiz series FX570EX, right? You can actually try and make sure that the display shows this way exactly how you wrote it, right? And then you just press equal sign. If you use any older model that is a bit more in line, then you make sure that you put enough brackets to make sure that the calculator will be calculating it in the order that you want, so that it's actually calculating this. All right, so anyway, with the correct calculator skills, right, you will get this result, 594.966. And of course, the standard in A levels is that you answer in 3 significant figures, right? You are allowed to round to 3 significant figures. So in 3 significant figures, this is actually very, very close to 595. And so if you did get your unbiased estimate of the population mean mu to be 309, and also your unbiased estimate for the population variance sigma squared to be 595 here, then you have done a good job. All right, and then you can move on to the next part. All right, so the next part is to calculate a 95% confidence interval for mu. Now, because we're now calculating a confidence interval, this is sort of like a two-tail kind of situation. So in order to figure out what are the critical value that we have to use in our MF19, we have to take the alpha here, in this case if you think about it as an alpha of 0.05, and we have to divide it by 2. And so when we do that, right, we do 1 minus that alpha divided by 2, we will get 0.975, and this value here is what we will use in order to find what is the critical value, and that critical value is 1.96 in this case. All right, so this is we always have to do this for finding confidence interval, right? Remember, just take the 5%, right? 100 minus 95% is 5%, so 5% is 0.05 divided by 2, and so you do 1 minus that and you get 0.975. So do not use 0.95, we have to use 0.975, and in the MF19 that correlates to the z value, the critical z value of 1.96. And so now we will calculate our confidence interval. This is the formula. You need a point estimate. In this case, we did calculate the point estimate. In this case, the unbiased estimate of the mean. We will use that later. Plus and minus the z critical value that we got. And this is our unbiased estimate of the standard deviation divided by square root of the sample size, right? So this confidence interval is based on this random sample. So we have to divide our estimate of the standard deviation with the square root of the sample size. So we have all the values now, so we'll just plug them in and we get this. Notice here that I didn't use 595, I used 594.966 based on the more accurate value, but I believe that even if you use 595 here, it should still work, at least to 3 significant figures. So also it is justified because you kind of already got this as a value before. So yeah, you can just keep 595 if you want to. But here, I'm a math person, I'm a stats person, so I like highest accuracy as possible in my working, so I put 594.966 here. But you're welcome to use 595. All right, so we calculate, and of course we have a plus minus, therefore you have to use your calculator twice, once for the plus and once for the minus. And so the result from your calculator, you should get something that looks like this. Now, very carefully, right, you must write this in the correct order. The left limit is 305.096 and the right limit is 312.904. I've had a student before that calculated the correct values but wrote this in the wrong order. He wrote the upper limit first and then the lower limit on the right. Because he asked me to mark his paper very, very strictly, I didn't give him the mark, right? I didn't give him the correct mark for that, right? And he agreed. However, I don't know. Some graders might be strict enough or as strict as me. Some graders might not be as strict and still award you the marks, okay? So, but just be very careful. A lot of students, they like to do the plus first and then the minus, and then they write their answers in the order that they calculate them. Don't fall into that trap, right? Always write the smaller value on the left and the larger value on the right. And of course, you don't really want to, or you're not really required to write all these decimals. You can always write them in 3 significant figures as your final answer. So we can conclude in the end that our 95% confidence interval, right, would be between 305 and 313, right, rounded to 3 significant figures. And if you do get this value, then you have done another good job. And with that, we move on to the next part of the question, where this time this is more testing on conceptual knowledge. So let's just read the question first. Another random sample of n cups of coffee is taken, where n is some number between 100 and 120. A 95% confidence interval for mu is calculated using this sample now. You may assume that for large samples, unbiased estimates of sigma square or the variance are very similar. Without calculation, state whether this confidence interval will be wider or narrower than the confidence interval found in part A2. Give a reason for your answer. This is 2 marks. So the 2 marks are for saying whether or not it's the new confidence interval will be wider or narrower, of course the answer, and also for the reason. So I'm going to give a long-winded answer, or maybe long-winded reason, I guess, and then I will end with the answer, right? Wider or narrow. Okay, let's just go on. So let's just analyze the formula for the confidence interval. We have a point estimate. That doesn't matter. It doesn't determine the width at all. What would determine the width, however, is this part here, because we're doing a plus minus here, right? So this will determine the upper and lower limits of our confidence interval. So what matters here is the value of z, the value of sigma, and the value of squared n. So the width of our confidence interval depends on the value of z, the unbiased estimate of the variance, which will lead to the unbiased estimate of the standard deviation, and of course the sample size n here, right? The value of mu does not matter in terms of the width of the confidence interval. So now in this problem, right, the value of z is the same, because we're still doing a 95% confidence interval. So that's out of the consideration for determining whether or not it affects the width of our new confidence interval. And of course our sigma is going to be the same as well, because here it does say you may assume that for large samples, unbiased estimates of sigma square are very similar. So we'll assume that this is very similar as well. So now the only the only number or value that will determine our confidence interval width is n. So n is different this time, because the original n is 150, our new n is somewhere between 100 and 120, right? So since our confidence interval, its width is inversely proportional to the square sample size, and a square roots is a one-to-one function that is also always increasing, and so with larger n, square root of n is also larger. Therefore, if you increase the value of n, then the width of the confidence interval would be narrower, and if you decrease the value of n, then the width of the confidence interval will be wider. So since the sample size has decreased, the value of n has become smaller, then the width of the confidence interval would increase, right? And so we can then conclude that the confidence interval for this new sample is going to be wider, right? Wider than the previous one. Okay, so if you do get this answer, if you did conclude that the new confidence interval would be wider than the previous one, then you have done a good job.